All right, so we've got a few people presenting today. I'll be last, Tom will be first, and then Brandon and Xiaoshu will talk a little bit about populated places and transportation. So first up, we have Tom to kind of introduce the topic and talk about rasters.
Thanks, Nathaniel. For a couple of years, you've heard us talking about version 6 of Natural Earth. We've been building the vector physical base, coastlines, streams, lakes, and so forth. That's complete, which means I get to go and do the fun stuff. You know what that is? Raster data. Pixels are pure. What you see is what you get. I just love working with rasters. Now, we've remastered all the rasters in Natural Earth. Well, one of the big changes is we're packing more pixels into the images. What that means is you could zoom in closer, the terrain won't be as pixely, and even more important, some of these Natural Earth data sets have rasterized vectors like the streams and the coastlines. They're going to be much, much cleaner. The downside is it's going to take a little bit longer to download these images. Originally, we went with that smaller size because we were doing this 12 years ago. We were worried about download speeds and so forth, but everyone has broadband now, right? Except for at this hotel. Okay, these are the data sets that we have. There's a lot of familiar images there. All the old things are remastered. We also have some new stuff. There's Gray Earth, which uses Daniel Huffman's localized hypsometric tints. We now have a dark version of that. So if you need a dark base for putting all kinds of glowy thematic data on top of it, that's the one to use. The ocean bottom data, we previously had that darker one on the right. We now have one with lighter shallow areas. So if you have a darker land area, you could have really nice figure-ground relationships between land and water. And we also threw in, just for the fun of it, MODIS land cover data. And I'll have a little bit more to say about that in a few slides. Okay, the other big news is we've remastered the shaded relief that goes on all the Natural Earth files. Look at Natural Earth 5 on the left. I was really proud of this 12 years ago. I thought it was great. I'm cringing a little bit now looking at it. The new version, we used Edward for rendering the relief, and well, I'll say no more. There's a big difference. Now, we're looking at the Himalaya here. Let's go to another area of the world and look at the shaded relief. This is centered on the Colorado Rockies. We now have 4 versions of shaded relief available to you. This is the most generalized version. Sometimes you need less detail. But if you need slightly more detail, here's our generalized version. A little bit more detail yet? There it is. And here's the most highly detailed version. Now, experience tells me everyone's going to be downloading this one. People seem to like detail and shaded relief, but sometimes less is more. Now, regardless of which shaded relief you use, they all fit very tightly with the drainages, so you don't have to worry about that. Those drainages fit snugly into the river valleys. Okay, I told you we're going to talk about MODIS data. We grabbed 500-meter MODIS data. Rob Simon helped us convert that from the awful HDF format to GeoTIFF. Thank you, Rob, if you're in the audience. It was a big help. I couldn't have done that myself. This is 500-meter resolution. The entire data set is 86,400 pixels wide. So this is a Mondo data set. Now, like all Natural Earth raster data, it's buffered into water bodies. So if you use our Natural Earth water bodies, it'll fit perfectly. But if you use other water bodies, shorelines, it'll fit perfectly because all the raster data goes into the water bodies. And what's more, we have a couple other versions of this, more generalized. And here's a real generalized one if blobs are your thing. And one of the things we've done is there's a legend for this, specifying what all the classifications are. It's right in the middle of the Atlantic Ocean. we process this in a way that we preserve the clean pixel edges, so there's no anti-aliasing. So if you don't like the colors that are in here, in Photoshop, just get your magic wand tool, click on the legend, it'll select all that color, and you can make those changes. Okay, there's one more thing. We now have new coral reef data for the world. This was originally a raster data set from World Resources Institute. I vectorized it. So this is not this is not raster data. It's vector data. It's clipped to shorelines. And one thing about this, there's a caveat. Unlike all the other data in Natural Earth, which is in the public domain, this one actually requires attribution. So be advised, if you do use the coral reefs, you have to attribute it. Okay. So, since I'm talking a little bit about vector data, I think we need to talk a little bit more, and Zhao Xu is going to tell us about transportation.
Thank you so much, Tom and Nathaniel. So let's look at the transportations. So those are the old data sets, like where the roads are classified into different categories, and I'll show you how it looks like now. So this is a new road data set I have finished all over the world. If you look at the more specific areas around the world, here are 4 examples focused on different continents: DC to Philadelphia, Shanghai, Hangzhou, Sao Paulo, Campinas, and Abu Dhabi, Dubai. You see all the road attributes got updated. We now have 2 sets of attributes, one with the prefix and one without the prefix. So you can do that all possible. And also including that fallen bridge in Baltimore, if you can notice that. There are other attribute fields, like including the tollways, whether the road is tolled either by toll station, electric toll collections, or like the vignettes. If you go to Switzerland, Bulgaria, or Romania, they require you to put a little sticker on the car. And also the bridges and tunnels. Those are new features for Natural Earth. We have all the tunnels over the world that is longer than 6 kilometers labeled out. You see on the left, the Tunnel du Mont Blanc between the France and Italy got labeled out, and also all the bridges and tunnels crossing the ocean, you can now label them. The airports, I have updated a lot of new opening airports, including the Berlin-Brandenburg airport and also the new Istanbul airport. Like there are a lot recently. And this is an ongoing process. And also the railroads. It is also an ongoing process, but you see, like in the future, we will have the more detailed classification on the normal railways and high-speed railways, and also other attribute fields such as passenger trains and hopefully gauges too. So those are the updates for the transportation layers. And let's turn to populated places. Brandon.
All right, so this has been a process. There were a lot of points in version 5 for populated places, and for the most part, we've kept them. There's a few that we're flagging for deletion. You'd be amazed how many Soviet gulags have survived in map after map after map. So there were a few places that actually don't exist anymore. But I don't know about you, but I found that even though Natural Earth is supposed to be at a scale of about 1 to 10 million, when you get down to 1 to 10 million, this is a little sparse a lot of times. So we've tried to work on that, starting with a curated process similar to what's happened previously in Natural Earth, of going through manually, looking at atlases, getting ideas of what's there, looking at upgraded population data. We have updated all the population figures for the cities using census data and other estimate sources. So this is points that have been added. Xiaoshu is really good at doing a lot of East Asia and South Asia and Southeast and Oceania. Kate, is Kate in here? Kate helped a lot getting Africa started, and I had some students help me with South America. But it's a lot of points. Not quite doubled, but added quite a bit. Just recently finished Africa. You can see that we have one section of the world left to do, which brings up the next thing is, just in the last couple months, Nathaniel is going to talk in the next session about the work that he's been doing on Who's on First. But as part of that, he said, "Hey, well, let's just see what Who's on First points might fill these gaps automatically, and try to make suggestions about this." So this is a set of points that Who's on First kind of fills in gaps. It also, on this one, by the way, the goal here was to get it down to a nominal scale of about 1 to 9 million at a moderate density, moderate to kind of moderately high density of cities, which is Zoom 7. So here, this gets us down to about 1 to 5 million. That's kind of the nominal scale we're shooting for here with these points. So as part of that, adding all those population figures, I also tried to rethink how the scale rank works. Just by show of hands, those of you who use this data set, how many of you prefer the scale rank over MinZoom? Oh, there's a couple of us. All right. How many of you use MinZoom more than scale rank? All right. Nathaniel and I have gone the rounds on this. So we're going to try and get those in sync, actually, so that you can pick and you'll get kind of the same results. But I've actually kind of rethought scale rank. It was getting a bit haphazard, the scale ranks were. There was gaps and such. So now what I'm proposing is that the scale ranks actually go kind of 2 scale ranks for every Zoom level. And so you go down to Zoom 11, and you can see here on this table what was originally there in the middle was 5, and then what we've added, and you can see we've kind of been adding more at the bottom. Here's some example maps. So this is at Zoom level 6, which is a scale of about 1 to 18 million at a moderate density. The points highlighted in purple there are ones that were added from the curated process. So there's a few that are bubbling their way up into the higher scales, but mostly that was points from version 5. Once you get down to Zoom level 7, this was kind of the base scale that I was working at for a scale of about 1 to 9 million at a moderate density. And you can see there's a lot more of the purple points, which are the curated ones. And then there's also a lot of the orange points, which are the ones suggested from Who's on First. We are seeing some issues. There's a couple points on there, the orange ones, that aren't actually that big. But so there is some curation that needs to happen with those Who's on First points still. And maybe some of you might be able to help with that process. But it does enable us to go down another Zoom level. So this is going down to Zoom 8, which is 1 to 4.5 million about nominally. And now you can see there's a lot more of those orange points. And you can see that the density does vary, but that's kind of the nature of population density in the Great Lakes area. I mean, it is, Rwanda is very dense with a lot of cities. So that's where we're at there. So. Okay.
All right, we have one more collaborator, Emre Samu. He's based in Hungary, so he couldn't make it today, and I'll be speaking to his slides. Natural Earth, from very early on, has held hands with other mapping data sets out there, primarily geonames. More recently, we've added concordance or crosswalk with something called Wikidata. You're probably more familiar with Wikipedia. You can kind of read it. It's beautiful, it has pictures. There's a sister project called Wikidata, which is structured data under a different license. So generally speaking, we add a Wikidata ID to all the features. That allows us to say, hey, this is a real feature, not something we made up or something that's been bad photocopied into maps again and again. But more importantly, it allows us to add name translations. Names in Spanish and French and Arabic and Chinese. So this process for version 6, we just finished it up for rivers and lakes. Populated places is almost finishing. there's a lot of new rivers and a lot of new places in this new version. So we want to make sure that the internationalization, the localization that we've added the last couple of releases is able to continue. The work here is mostly in databases, trying to match up Wikidata with Natural Earth. Wikidata stores points for features. Most of our features are really long rivers or bigger lakes. So, in the past, we've used a heuristic-based model saying, hey, if these features are close together and they have a similar name, not necessarily an exact match name, they're probably the same. There's some problems with that approach. But in this new version, we've added an ChatGPT LLM kind of extra step. And we basically say, we give the large language model a prompt, and then we can say, hey, is this thing probably the same? And it turns out computers are very good at this type of pattern matching, especially for names that you've never seen before. So some examples here, good, maybe, and bad. It's able to say, we're able to give it data in a slightly different taxonomy. We say, hey, there's an intermediate or dry lake. In Wikidata, that's an instance of a salt lake or an instance of an intermediate lake. We see that there's a nearby feature within a couple kilometers, in Iran in this case. And the names look very different, but if you start decomposing them into, oh, well, what is lake in Farsi? What are some of these other kind of interstitial words? You can very quickly see that, oh, the top example, it's actually the same place. The bottom example, not at all. So these large language models are actually helping us take some more rigor with this work. There's a lot of kind of problems when you're working with large geographic data sets around the world. Generally speaking, like in Who's on First, we have like 5 million places. There's a lot of populated places around the world. There's a lot of rivers and lakes. And so trying to work with this larger data set also means that you're working with data sets that have problems in them. You're working with messy data. So there's a link down here where you can read more about some of the problems in that work. I think one thing that we think about a lot in the Wikidata side and also Natural Earth is we're making a primary data set that other people are referencing. The problem is if we introduce an error, then everyone that uses the product also kind of perpetuates that error. In the Wikidata world, that's called cytogenesis, basically where someone slips a little bit of fake news in, and then it becomes fact that everyone else references. Just to put it in more of a meme term, sorry, Tom, there's, everyone's pointing at everyone else, and, what's the truth? So this is something that as we work on this new version and add all this new authoritative data, we're trying to spend a little bit of time making sure we get right. So thank you so much. There's a link to the shadedrelief.com Natural Earth draft. Up there, you can use your QR code on your phone to pull up the same thing. So we have just published, the rasters have been up for a month or so on the site. I think this week we added the transportation download. Roads and airports. So we're working, I think in the next month or so, we should have the populated places up for folks to download. With this work, it's been going on a while. It's a lot of nights and weekend work, so thank you for your patience. But we're trying to release this data kind of as we finish each theme, so we can get feedback from everyone. So if you're interested, please find Tom or myself, Brandon or Xiao Xu. We'd love to talk more and hear your feedback. I'll post links to the slides, including the LLM prompt, if you're interested in doing the same thing at home. Thank you.